prefix evaluation. And one of the suggestions was that can we use, let's say, an operand stack and the operator stack. We push operands to the operand stack, and then whenever we have two operators available with us, can we just pop the operator from the other stack and evaluate that and push the result back. Unfortunately, some of you also suggested that that algorithm doesn't work, and we might have to think of something else. One of you had also suggested that can we do this expression evaluation from right to left and see if that works out. The advantage of that is that in the prefix, for example, plus AB, A and B will be visible or they're available in the stack by the time you reach plus, exactly in a similar manner that postfix evaluation happens. So does that work out? It turns out that it does. And the algorithm remains almost the same as what postfix is. So if the symbol is an operand, we just push its value to the stack. If it's an operator, then we pop the two elements from the stack, apply the operator and push the result back, assuming that all the operators are binary. If the operator turns out to be unary or ternary, then accordingly we'll have to pop those many number of elements from the stack. Right? And it turns out that the algorithm otherwise remains the same, and there are some error conditions that we need to worry about, etc. Right? But otherwise this works. So for example, if I have all these different operators, prefix expressions, then we go from right to left. As 4 comes, we push 4, then we push 3. Then as minus comes, we evaluate, what do we evaluate? 3 minus 4 or 4 minus 3? We should be evaluating 3 minus 4, right? So, right, as Naimisha says, should be evaluating 3 minus 4, and that value gets pushed back into the stack. Once we have that, and that is also, if you notice, that is also the reverse order of how the evaluation should happen, right? So when you had, when we had thought about this expression, we said that plus 1, 2 should happen first. Right? However, we are currently doing minus of 3, 4. Right? Does it create a problem? Well, we'll see that it doesn't. So minus 3, 4 is getting pushed to the stack. And I mean, the value minus 1 is going to get pushed to the stack, which means that that is the second operand of the operator star. So that is going to be pushed below in the stack, and therefore it will be taken out in the end. Right? Just that the evaluation is happening from right to left. Then when plus 1, 2 comes, at that time we evaluate that. Again, 2 gets pushed, and although there are 2 and minus 1 in the stack, we don't remove the elements. We then encounter 1, which also gets pushed. So now the stack contains 1, 2, and minus 1 in that order. When plus comes, it pops 2 elements from the stack and applies it as 1 plus 2 and pushes the value 3. And therefore the stack contains 3 and minus 1. When star comes, we essentially evaluate that and we get minus 3. Let's do it quickly for some other, let's say this expression. So when 4 comes, then 3 comes, we push, 2 comes, we push, 1 comes, we push. When plus comes, then we evaluate this part. Then when star comes, we evaluate the value of plus 1, 2 as well as 3 as a multiplication, and so on. Right? So please think about this, how this is getting done, and your homework is to code this up. But if there are any questions, concerns, if you want to run it through all these prefixes that I have given, please feel free to do that. I'll wait for a few seconds for any questions. Okay, Salman says, if we have functions in place of numbers, won't the order be important? Yes, that is correct. For example, so what Salman is suggesting is that if I have operators which have side effect, then the evaluation order becomes very important, right? And in that case, this kind of operation will not work. You can at max have some sort of a lambda computed for, I mean, essentially non-evaluated template computed for that operator, and then push that to the stack, but you have to evaluate it only later. But that is not going to give you. So this give you the correct, in general, you will not get the correct answer if there are operators which have side effects. For example, if you have plus plus operator, it has to be done later, right? If you do it first, then that is going to cause some problem, right? Similarly, functions. For example, if this 4 and 3 were functions, then they may have other side effects. For example, they might change global variables, they might have some printfs, and we don't want that to happen in the reverse order. In such cases, this algorithm is not going to work. This algorithm works only for expressions which do not have any side effects. Okay. Good, that's a good point. Any other concerns, questions? Note that if we do a postfix evaluation, then this problem will not occur because the evaluation will be from left to right. However, yeah, maybe. So I was thinking about logical operators, where there is short circuiting happening. I think that can also be handled by postfix. It will not be handled by this prefix evaluation, but postfix will be able to handle that too. You will have to make changes to the evaluation of that operator, but I think it's possible. Okay. Any other concerns, questions? Murari is asking, is postfix and prefix related somehow? Can we convert from one to another at least in least time complexity? So, okay, this particular question has a very interesting answer. It turns out that if you are given a postfix, okay, let me just recall that. If you are given a postfix, there is one particular way in which you can evaluate. Can you convert it into the corresponding prefix? So whatever I'm recalling is that if you just have a postfix, you cannot convert it directly into prefix and vice versa. Right? So it's I think it has some ambiguity somewhere. I'm not able to recall properly. Does anybody know whether postfix and prefix can be interconverted without ambiguity, or there is some problem which occurs, which is what I'm currently thinking about, or that's what is coming to my mind, that postfix cannot be unambiguously converted into prefix and vice versa. That is what is there in my mind. Okay, I'll have to look this up, Murari. I am not able to recall. Yeah, but that is what I remember. Yeah. Any other questions? Okay, Mayank has given this link, postfix prefix conversion. So looks like we can do it. Thanks for that link, Mayank. So hopefully that will answer Murari's question too. Great. Any other concerns here? Okay, so we'll move ahead from here. Let's say that we are given, and so what we did so far is that we manually converted infix to prefix postfix. Then we evaluated postfix. Then we also evaluated prefix, right? So we have these with us. Now what we are trying to do is to that manual part of infix to postfix, we would like to do it programmatically. So given an infix expression, we would like to convert it into a postfix form. Right? How does one do that programmatically, right? As an algorithm? Can somebody suggest that? So please think about it, and if you think of a way to do it, please post in the chat box. So this kind of expression is also sometimes called as fully parenthesized. It is not technically fully parenthesized, but in fully parenthesized, even 1, 2, 3, 4 will be in parenthesis. But anyway, assuming that that is not the problem, these are for our purposes fully parenthesized, and we would like to convert these because the precedence is now given. Right? So you are given the order in which the evaluation must happen using the parenthesis. Now using that, can we convert? So then that means that there is a unique evaluation order of this infix expression, and therefore postfix, well, there is only one postfix corresponding to that. So that is going to be our problem, how to convert this. Whenever parenthesis closes, enter the operators in reverse order is Saicharan suggestion. Operands will retain their order. Whenever parenthesis closes. So after 2, when the parenthesis close, enter the operators in reverse order. Okay, so plus gets pushed. Okay, then star comes, then 3 minus 4. So we push in the reverse order, that is minus and then star. Okay. And as soon as that reverse comes, that means that we are probably going to use a stack there. Right? So we maintain an operator stack, and that is probably going to get used in Saicharan's algorithm to push the elements, to push the operators to the postfix form. Okay, let's also check if that is working out for other expressions which are given as examples on the slide. Pavan says use 3 stacks, one stack to read parenthesis, one for operators, another for operands. Okay. As we read the string, push items into their stacks respectively. Once a balanced parenthesis is seen, convert the elements in operator and operand stack to postfix. Yeah, so here also there seems to be based on the closing parenthesis, because that is the time when you will look for the matching opening parenthesis. Convert the elements in operator and operand stack to postfix. So you take the operator from the operator stack, take 2 elements from the operand stack and do it. But that's a little bit of worry there is that we are not evaluating the expression. And therefore, for example, when I am evaluating the third expression and I reach 4, that is I mean something minus 4, right? That something is not one element, and therefore it might turn out we will have to be a little more fine-grained there, Pawan. It won't be a number. It might not be a number always. Andrea says encounter a bracket, then push operator, last operand, first operand, last operand to first operand. Okay. Push the operator, then the last operand, and then the first operand. I see. But when you encounter a bracket, push which operator? And pop until we have removed one opening bracket. Yeah, I think some of us are probably thinking in terms of binary. That is okay for now. As Murari has suggested, sometimes we might have to worry about multiple removals from the stack. Okay, so I see some discussion. I hope some of the other students are also thinking about it, although it is early in the day. But okay, so let's look at that particular infix to postfix conversion. So the algorithm goes quite similar to what you guys have suggested. So for each symbol in the expression, right, if it is an operand, that is the number or something, just print the symbol. Right. So whenever you are encountering a symbol, encountering an operand, a number or a variable, just print it because that is the order that in which that is going to happen, right? Because the operator is going to come later. Right? So, or you can push it to a string, doesn't matter. Otherwise, if it is an opening parenthesis, then you maintain a stack on which you just push the opening parenthesis. Right? Otherwise, when it is a closing parenthesis, this is where there is similarity with your suggestions. Then there is some processing which we will do, right? Otherwise, that is, it's an, sorry. Otherwise, if it's an operator, which is, let's say plus minus star slash, then we perform something else, right? Of course, there is, I mean, there is no error checking currently here, but ideally this else part will have, if it is an operator, then perform this processing, otherwise give an error, right? If it's an invalid symbol. Okay, so let's understand this closing parenthesis part and then the operator part. Closing parenthesis says that the way Murari was suggesting that we have to remove elements from the stack until we reach the opening parenthesis. And opening parenthesis is going to give us the leeway because the expression is fully parenthesized except the independent numerals. So we pop the elements from the stack, and this makes sure that it, what to say, yeah, this will work even if the arity of the operator is something else, not necessarily binary, right? So this particular do while loop makes sure, otherwise you will just have pop two symbols from the stack and so on, right? So that is another way in which this can be done. So we pop the symbol from the stack. If the symbol is not opening parenthesis, right, then print the symbol, right? So essentially you are just popping out the elements and printing those. This will also work for expressions like a plus b plus c inside parenthesis, but we are saying that the original expression is fully parenthesized. So this will appear, a plus b plus c is not a fully parenthesized expression. It will have to be a plus b in parenthesis followed by plus c in parenthesis. I mean, all of this in parenthesis. So that we can assume, but even otherwise this code is going to work because you are going to go from left to right, right? So for each symbol in the expression, this outer for loop is going from left to right, and the associativity of these operators is from left to right. What is meant by associativity here? What is meant by associativity of an operator? So I should mention that there are two aspects which come into picture when we are dealing with expressions. One is precedence, which we usually study when we are learning C, and the other one is associativity. Precedence, we know that star has higher precedence than plus, right? So that we know of. What is associativity? Okay, Shania is saying a plus b plus c equal to a plus b plus c. Right. So this is the associativity property of plus, which means that you can evaluate it in any order. Right? But with respect, so that is correct. That is not a wrong statement. In the current context, there is something else that the associativity plays a role with. So, for example, let me mention to you this way. When there are two different operators like plus and star, then the precedence comes into picture, that which one should be evaluated. 2 plus 3 into 5. So we know that star has higher precedence, so 3 into 5 should be evaluated first. When the two operators have the same precedence, then it is not clear in which order it should be evaluated. So a plus b minus c, plus and minus have the same precedence. So which one should happen first, b minus c or a plus b? That is decided by what is the associativity of the operator. The associativity of plus and minus is left associativity, which means that a plus b should happen first and then minus c. In a similar manner, a plus b plus c without any parenthesis, a plus b must happen first and then plus c. That is decided by the associativity. So when the operators have the same precedence, then associativity comes into picture. Do you know any operator which is right associative in C? Prefix operator. No. Prefix, only because it is appearing on the left hand side of the operand doesn't mean that it's a left associative operator, because essentially you cannot have multiple occurrences of the prefix operator plus a, right? So I think that is not possible. Pavan says unary operators are right associative. So not of a, so you perform the innermost first and then the outermost. Yeah, maybe that is correct. Any binary operator you know which is right associative? Pavan says assignment operator. So a equal to b equal to c. B equal to c happens first, and then a equal to whatever is the return value of b equal to c, that happens, right? So the assignment operator is right associative. That's okay. That's good. Why does this left associativity, right associativity kind of come into picture? Okay, Abhishek is giving star of plus PTR. No, I think the precedence of these two operators is different, and therefore the associativity will not come into picture here. Right, so I think plus has a higher precedence over star. So anyway, in this case, it is going to be that way. But for example, if you have star PTR plus, then I think PTR plus is going to happen first. It is going to return the value of PTR and star, the original PTR, and then the star of that is going to be returned. Right, so the operator precedence is different. But good, this discussion is good. The one thing which I wanted to mention about the left associativity is that it makes a difference when you have, for example, minus and division. So if I say, and it will look a little odd, please pay attention to this, a minus b minus c, a minus b minus c, this should be evaluated as a minus b and then minus of c, right? This is what we know because of left associativity. If minus operator would have been right associative, the way we would have done it is, we would have done b minus c first. Note this, that we are doing b minus c first and then a minus of whatever is the result. Is that giving you the same answer or a different answer? Okay. Shania, Murari say different, Salman says different. Yes. What we are actually evaluating is A minus B plus C, right, in our left associative form. So this is an important point when it comes to operators which are not commutative. A minus B is not same as B minus C, and therefore that associativity part will play a role when you reverse the order, right? So anyway, so that's more like an aside, but I hope you get the point. So until you reach the opening parenthesis, you go on popping the elements and push them to the output, right? If it is an operator, then depending upon the operator, we have to decide how many elements to push, how many elements to remove from the stack. So we look at the symbol in the stack while the symbol, okay, so this is where the priority also comes into picture. But so that means that this code is going to work even if you don't have fully parenthesized expression. But if you have fully parenthesized, then you don't have to worry about this. So while the symbol D has higher or equal priority than C, right? So the symbol C is coming from the input, right? So think about it as plus operator. And then the, okay, let me give you an example. I think that will make it much clearer. So let's say that our language supports exponentiation operator, right, which has the higher precedence. It's a binary operator and has higher precedence than plus, star, etc. So now if the expression is like this, A plus B exponentiation C star D, right? This is the expression that is given to us. And the way our algorithm works, A comes, we push it to the stack. Sorry, we print it onto the screen. Then plus comes. At this stage, we look at the top of the stack. The top of the stack does not contain anything, right? And therefore, sorry, we are talking about postfix evaluation. Sorry, I gave the infix. No, this is fine. We are not evaluating postfix. We are converting from infix to postfix. So this is okay. So plus comes, we peek at the stack, but the stack is empty. So we don't have to worry anything. And therefore, we just push that symbol plus to the operator stack. Now, I mean, to the stack essentially. So maybe I should convert this. Okay, I think I'll not convert it into parenthesized form, because for parenthesized form, this is going to work. We don't have to worry. But in this case, since there are no parentheses, we have to worry about whether plus should be applied as soon as B is available. Whether plus should be applied as soon as B is available, or we should wait for looking at the next operator, because next operator might have higher precedence than plus. And if that is the case, then plus should not be evaluated now. That means that whether plus should be printed or not as part of the postfix is decided by the next operator. So caret is the next operator, which is going to decide whether plus should be printed or not. And it says that don't print plus right now, because caret should get printed first. Right? So the precedence of the, so when you reach a caret or exponentiation operator, at that time you will figure out that okay, at that time also you have to see if, okay, I'll just going to change the expression, which will again make it complicated, but I think that will also be better for our discussion. So when plus comes, when B comes, I cannot print plus because I need to wait. So I push plus. When star comes, I know that star has higher precedence than plus. So therefore star should get printed first, but I cannot still print star because star is not the highest precedence operator. There may be some other operator which is coming, and in this case that is what is happening, that assuming that exponentiation has higher precedence than star, I need to still wait. So I will push star also. And then when I encounter exponentiation, I should probably wait even for exponentiation, because there may be another higher priority, higher precedence operator. When the no other operator comes in, at that time I can pop the operators and print the symbols. That is the last while loop in the code. But otherwise, in the previous expression, a plus b cap c star d, when star is encountered, when I look at the top of the stack, I see cap operator, that is the exponentiation operator, which has higher precedence. So I print cap. So I encounter a, b, c cap, and that is correct, because b, c cap should get evaluated first. Then I push the star to the stack, because I don't know what is coming after d or after star. Right? So therefore I push star. So now the stack should contain plus and star. Right? So when D is encountered, at that time, again, I just print D. And after that, since the input is over, I empty the stack in the reverse order, and therefore I'll push star and plus to the output. Right? So that is what is essentially the loop that is happening here, that while D, that is the one element which is being pushed from the, being popped from the stack, has equal or higher priority. Higher priority is understandable, but why equal? Because we are assuming left to right associativity. That is not always the case, and this particular algorithm that I am showing will work only for left associative operators. If it is a right associative operator, then D has higher precedence, then C will work as it is. But if it is equal priority, then I have to print the symbol C rather than D. Print the symbol that is coming from the input, right? But again, that I cannot do right now, because there may be a higher precedence operator that is probably coming in future, right? So I need to wait even for that. So anyway, so those complications will occur for the right associative part. For the left associative, this code is going to be just print the symbol that is coming from the stack and pop the next symbol from the stack, and go on doing it until the higher precedence operators are there in the stack, and those are all exhausted with respect to the current operator's precedence. In the end, we push this symbol that is coming from the input to the stack. We don't print it to the output yet, because we need to look at the future operator. This whole process goes on until the string is over, the expression is over, and in the end, the operators are essentially popped from the stack and printed. Any questions on this algorithm? Anything that is unclear? Okay. Okay, so then I'm going to move ahead. These are the different parts of the algorithm which we have already discussed. There is one small piece, yeah, so that, okay, so that infix to postfix, I think we wanted to see the code. Let me just unshare the screen and share the other window. Okay, so the code goes like this. We again have the IO stream, stack, string, and I'm using a new STL structure now, which is called as a map. What is a map? Map is essentially a key value store. Key value store meaning that, for example, we do arrays, right? So where the indexing is being done using integer, a of I equal to something, maybe a of I equal to ABCD. So I becomes the index, that is the key, and ABCD becomes the value. In a similar manner, I can have an indexing based on arbitrary type. It need not always be an integer. So that is what I'm using a map for deciding the priority of or precedence of the operators. The operators are given as characters, and their priority I'm deciding a priori, right? So I'm having this map populated at the start of the program itself, which I'm just using for the get priority operator. So that is precisely what is going to happen. That priority of an operator C is going to be priority of C, very similar to the array indexing, but this is not an array, this is a map. Right? Okay, so we'll quickly look at the main first. So main is relatively simple. What I do is I have an infix string which is given as an input, populate the priority, which is essentially populating this map that we just saw. We take the input string in the infix form, and then I just call infix to postfix on that infix, and I print it. Right? So that is what keeps happening in a loop. Plus and minus have priority 1, star and slash have priority 2. That's it. But I have done it this way. I mean, this can be easily checked inside the code. I don't need to really populate a map and all. But if you want to extend this for more operators, you will be able to quickly do it, and the same code will work. You just need to update the priority map here. Right? All right. So note that we did not allocate any memory anywhere, right? So all of this, we just declared that map initially global, and we did not specify any size there, unlike in arrays. And we just go on populating it with newer and newer elements, and that takes care of internal memory allocations, etc. Very similar to the vectors where we do the pushback. Okay. We'll look at the code, but any questions so far? All right. So we'll look at the algorithm, which is similar to what we have in the slide. So we have the operator stack. The operands need not be stored because those are just getting printed in the same order. As soon as you encounter an operand, you just print it. Right? So in this case, we are not printing it because we need to return it as a string. So therefore, I am returning the postfix as a string. So that should be declared as a string here. Right? And then there is this stack of characters which I am maintaining. Right? So then I go over the whole string, the input expression. Whatever is the character, if it is an operand, then I just print it. I mean, in this case, I am just pushing it to the output string. If it is an opening parenthesis, then I just push it to the operators. If it's a close parenthesis, then I need to extract the elements until I find the open parenthesis. That is what is being happening here. And as you encounter the elements, you just go on pushing it to the stack and pushing it to the postfix string or print it to the output, and then we go on popping the next element, and this happens repeatedly. Right? So why is there no check for an empty stack here? Any suggestions?
If there is closed parenthesis coming, some elements will be there.
So in some sense, yeah. In some sense, this is assuming that the the infix expression is correct. Right? If it is not correct, then we have to worry about the error condition. So that error processing should have been there, but I think just to reduce the size of the code, I have not checked that. But yeah, in general, for arbitrary infix expressions, you might encounter a situation where you will see empty stack here, because the infix expression can be arbitrary. It's coming from the input. It is not sanitized or filtered, and therefore we should do some error checking there. Okay. So yeah, that's what happens for the closing parenthesis. When it is an operator, then we need to worry about precedence. So we peek at the element, and while it has a higher or equal priority, D has a higher priority than C. then we pop it and print it. And yeah, here there is a small check that if it is empty, then we just break out. If it is not empty, then we just peek at the top of the stack and we go on doing it. So we first check the priority and then pop the element, right? So that is important. And in the end, this particular operator that we are looking at, that needs to be pushed to the stack because there might be a higher precedence operator coming in future. In the end, we just, whatever is the remaining stack, we just print it. So we pop the element and go on. So popping, yeah, so that the peak and then pop. So we pop the element and keep pushing to the output. So that is what is the final part of the code. That is what we saw on the slide. Any questions on this part? Okay. Then there are a couple of auxiliary operations or functions that we have. These are similar to what we had earlier. Get priority just returns priority of C. Is operand is whether it is A to Z or 0 to 9. So this works for even variables and single digit numbers. Opening parenthesis, closing parenthesis. Again, this is something which can be directly checked inside the program, but it makes it easy to modify the code later if you want to, for example, support some different kind of parentheses, etc. Higher or equal priority, well, you get the two priorities and check if the priority of C is less than equal to priority of D. And then there is a logging function just to print the stack at different places, which is used for debugging purposes. All right, so let's quickly run this and see if it gives us the correct output. So let's take that 1 plus 3 says 1 3 plus. So 1, okay, we'll give our operator 1 A plus B star C slash D. So as you can see, the star and slash should happen first in that order and then plus. So that is what it converted, and therefore it had to pop, it had to peak at plus and decide, okay, plus is a lower priority operator, and therefore let me not do anything with respect to plus. But if star had appeared first, then as soon as you encounter plus, you can guarantee that star should be evaluated first, and therefore that star will be popped from the operator stack and will be pushed to the output, and so on. You can play around with this for larger expressions. If anybody wants to try any specific expressions, please let me know in the chat. I'll just copy and try to. All right, so let's assume that this is fine. Let's go back to our slide. Yeah, so one small, okay, let me just reshare. So one small part that I wanted to mention is, sorry. So I hope I have shared the full screen now. Yeah. So is about the recursive formulations of this infix, prefix, postfix, right? So this is something which we didn't do as such. We just said that when the operator appears in between the operands, it is infix. If it is before and after, then that becomes prefix and postfix. But there is a more formal way of defining this in a recursive manner, and that is what I wanted to just quickly mention, although we know it by now, but just for the sake of completeness, because while discussing with Dr. Meghna, I realized that this can be a good way of formulating. So she suggested me to add this, so I have added this. So infix is in the recursive formulation, we have the base case and the inductive case. So the base case says that each operand is an infix expression. Right? So each variable, each number, that is an infix expression. Right? So that is the base case. And then the inductive case says that infix operator infix, that is some expression which you have in infix form and some other expression which you have in infix form, and you combine this with an operator, typically binary, then that becomes an infix expression. You can also talk about infix op, or op infix becomes an infix expression if op is a unary pre-operator or post-operator, etc. Right? So that is also another way in which that can be done. And in a similar manner, we can talk about postfix, that each number or variable is a postfix, and then postfix op becomes the postfix. Sorry, I think I have written it wrong. This should be op postfix, right? And prefix should be the other way around, prefix op. So sorry about that. That needs to be corrected here as well as here. Right? But I hope you get the point. So this is a recursive formulation of infix expression starting from the base. Right? So you start from the smallest atom possible, and then you build upon that in a recursive manner. And then you can build arbitrary expressions. All the possible postfix, prefix, infix expressions should be creatable, should be buildable using this recursive formulation. Any concerns, questions on this formulation? Okay, so then I think we have to worry about Q, and that we'll do in the next class. If there are any questions, we can take those up now. Okay, if there are no questions, then I'm going to stop the class here. See you in the next class.